Welcome to today's lecture. We are going to be looking at exponential and logarithmic functions, and we will be using a calculator this time. So make sure you have your calculators with you so that you can follow along on some of the examples and make sure that you know what buttons to use in making and doing correct work on the calculator. Up until recently, the calculator technology did not allow us to do things where we had a log with a base of x. We only have had two buttons that for log, and they are, if you look down here at my arrow, over here by the 7, we have a log, L-O-G, and one that says Ln, and that's our natural log. So we have log base 10 and log base e, but we don't have things like log base 3. So we could do something called a change of base in order to use our calculators. So we're going to use the change of base property, which says that log base b of x is the same thing as log of x over log of b. Notice that they are both base 10. This also works if we're using natural log. So I could do natural log of x over the natural log of b. So if I have log base b of x and I can use either one of those, I can type those into my calculator. I would type in, and x and b of course would be numbers, and you would type in log base whatever that is. Let's take a look at an example. And my example is going to be log with a base of, let's make it large, 78 of 4,212. So what I'm going to type into my calculator is log 78 over log 4,212. So I'll use my calculator and I go log 78, and then I end the parentheses that's given to me and use the divide button to type in the log 4,212. So log 4,212. Once again, end the parentheses, and when you hit enter, it'll be a nice long decimal, and we're going to round it to 3 decimal places. So I get 1.916. So I'm going to give you a couple to try, so just a moment and I will put those examples up there. Okay, so these are the examples that I'd like to have you try. I'd like you to do one of them with natural logs and one of them with logs, the common log. Either one will work with either one, so it doesn't make a difference which one you use. So use one with common log, where you use the log button, and then try one with the natural log, where each of the numerator and the denominator will be set to a natural log. So take a moment and see if you get an answer, and I will put the answers up on the screen and see if you're right. Okay, so did you check your work? This is the answer to log base 15 of 33 comes up to 1.291. The answer to log base 1/3 10 is going to equal negative 2.096. If you did not get these answers in your calculator, please work with one another and determine what did you type in your calculator that was incorrect, so that you can get these answers. Now that we've learned change of base property, and we also know how to go from a log And if we have a base raised to the exponent that equals a number, we can rewrite that as a logarithmic of log base b of a number equals e. We're going to use that and our change of base in order to solve some equations. So let's start out with an example. If I am given an exponential equation, 4 to the x is equal to 13, and I want to solve for x. I need to know how to do that. Well, looking at that, this cannot be written. We did some of these where we didn't use a calculator, but today I can't rewrite this with a base of 4. So in order to do this, I am going to have to rewrite the equation as a logarithmic equation. So I'm going to use this information up here, and I'm going to write this as log base 4 of 13 is equal to x. Well, when I did that, I have solved now. I have written the equation for x, and I can just put this into my calculator. And I'm going to use the change of base property. So I'll rewrite this as log of 13 over log of 4 is equal to x, and I'll type that into my calculator. And get the answer 1.8. X is equal to 1.850. In this example, we've been given a logarithmic equation, and I'm trying to find the natural log of x that's being multiplied by -3, and I know it equals -24, but I really want to know what x is, because that's what I'm doing when I'm solving equations. So I want to get that x by itself, and the first thing I'm going to do is divide by 3, or -3. So I'm left with the natural log of x is equal to 8. That still doesn't tell me anything. I don't know what the natural log of what x would have to be in order to get the natural log of x being equal to 8. So I'm going to rewrite this as an exponential. So this is, remember, this is log base e. So I'm going to have e raised to the 8th is equal to x. Now this is something I can put into a calculator. And I don't know if you remember me telling you, there are 2 places on your calculator where you can type in e. So take a look at this. Underneath the exponent button, if you go to second, there is a button that says e. That's just the value for e. It's a constant. we so often raise that to a power that they decided to make a shortcut down here, and is the second button of the natural log button down over here next to the 4. So if you go second natural log, it will give you e and then raised 2, and you just need to add in the exponent. So that's the button I like to use, because all I have to do is hit second, that button, and then hit 8 and enter, and I'll have an answer. Get the actual calculator here, and so 8, I have 2 x is equal to 2,980.958. We're going to 3 decimal places. We are also going to be using some of the properties that we learned in the no calculator portion for expanding, condensing, and our basic properties of logarithms and exponents. We're going to use those to solve this. I can't quite write this as a logarithmic equation, but I can do the same thing to each side of the equation. So what I'm going to do is take the log, and let's just use natural log this time. So I'm going to take the natural log of each side. I'm going to write this as the natural log of 6 raised to the 2x plus 4 equals the natural log of 5 raised to the negative x plus 1. And then we can apply the power rule to expand this. So our powers are going to become coefficients. So I have 2x plus 4 times the natural log of 6 equals negative x plus 1 times the natural log of 5. Remember, when we're solving equations, we're trying to get the x's all on one side of the equation. So I'm going to first thing I'm going to do is distribute this and distribute this one, so I can get the x's away from the constants and separate everything else. So I'm going to have 2x natural log of 6 plus 4 natural log of 6 equals negative x natural log of 5 plus the natural log of 5. Anything that has an x or a variable, I'm going to put on one side of my equation, and anything that does not have a variable, I'm going to put on the other side of my equation. They're not like terms, so I cannot combine them. But in this term, I can factor out that x. So I'm going to factor out the x, and I get 2x, no x, I just factored it out. So I have 2 natural log of 6 plus natural log of 5 equals natural log of 5 minus 4 natural log of 6. And I can divide by this factor here. That will cancel out, and this is what my x is going to equal, this thing. I can type that into my calculator, making sure that I put parentheses around the numerator and parentheses around the denominator. So I'll type parentheses natural log 5 minus 4 natural log 6 and parenthesis divide. then you're going to put another parentheses around your denominator, 2 natural log 6 plus the natural log 5, end your parentheses, and hit enter. And hopefully you'll get the answer. Let's go to 2 decimal places here of negative 1.07. One of the things that we do often with our exponential functions is to create an expansion or exponential growth formulas. One of the things that grows is money when we apply an interest to it over time. We have 2 compounding formulas that we're going to use. The first one is called periodically, which means if it's an investment and we put some money in that's earning an interest over time, every once in a while they will calculate what the interest is and add it in. Some accounts would be continuous growth, and this is the formula that we have for there. I know you guys have used those before, but let's look again at what all these letters mean. Now we wrote it, you may have seen it without the A with the parentheses T, but we want to, the A stands for accrued balance in both formulas. But we want it in relation to time, so that's why we put the parentheses T, and that makes it a function of time. So it's the accrued balance over time. The P, and accrued just means that's going to be at the ending, sorry. The P is going to be our principal balance. And that just means that's what we're starting out with. No interest has yet been applied to that amount. The R is our rate, usually given as a percent, but we are always in our formulas going to express this as a decimal. T is our time, and it's going to be measured in years. If it's not a full year that you are looking at, like if something was 3.5 years, you can put it in decimals or keep it in fractions, 3.5 or 3 1/2. And that would be fine, or 7/2 even, if you like the improper fractions. But it will always be measured in years. And then the last one only applies to our periodic because N is the periods, or the number of times per year that the interest is being added onto it. And there's some common ones that we're going to use. Obviously, if it's yearly, we're only doing it once a year, and so it's N is equal to 1. If it's semi-annually, and this is a word we don't use often, that just means twice a year. So it's going to be N is equal to 2. If we are doing it quarterly, compounding quarterly, N is equal to 4. If we're compounding monthly, N is equal to 12. And if we are compounding weekly, that's the other one, N is equal to 52. So let's take a look at an example of using this formula and applying those. So let's take a look at an example of how we would use these formulas. The word problem here states 2 banks offer a $10,000 loan for 4 years. Bank A offers a 3% interest, but it's compounded quarterly. Bank B offers a 2.75% interest, but is compounded continuously. Which bank charges less interest and how much interest, or how much less interest? So let's put the Bank A formula here. Our accrued over time, and our time is going to be 7 years, is going to be the principal, 10,000, times 1 plus our interest rate, which was 0.03, divided by the number of periods, which is 4, and we'll raise that to 4 times 7, or n times t. So we're going to enter that into our calculator and get an answer, and then we'll compare that to Bank B, which will set that accrued over 7 years, will be the principal times, oops, I didn't need that, E, raised to the rate, which is 0.0275, times the 7 years. So enter those both into your calculator and determine what answer you get. Hopefully you'll get the same thing I did. And Bank A is going to be $12,327.12, and Bank B will be $12,000, $122.77. Is that what you got? So the difference, I know I'm going to write this over my head, but well, which one charges less? The one that charges less is Bank B. And the difference is going to be $2,004.35. Yes, 35 cents. All right, hopefully that gives you enough information so that you can do your assignment and get that turned in tomorrow. See you later.